Hey y'all, we are Memphis Communiversity and we're back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. Today we're going to be continuing our shape of curves unit, and what we're going to do is we're going to try to answer multiple choice questions on shape of curves when graphs are already provided. So we are going to be using the same rules that we've learned before about increasing, decreasing, concavity, local min or maxes, and inflection points. But what's going to happen is that we don't have to draw our own side charts. We don't have to find f prime or f double prime because always the graph is already provided. And what we do need to know is how to use the rule for a graph. So what some teachers teach, I believe, is that they try to draw the graph of f prime or f double prime based off the graph of f, or whatever the given graph is. But what we're going to do today is we're going to use the rules that we know very well. For example, f increasing when f prime is positive. And we're going to use those rules to unite two functions, f prime, f double prime, and so on. And how we're going to do this is that we're just going to look at a picture and just answer the question. So some students really love this unit because they don't have to do any math. They can just look at a picture. As long as they know what they're going for and what they're looking at and the rules themselves, then they're usually pretty good to go. They just look at the question, draw a few notes, and answer the question. Some students, though, do have trouble with this because this is very visual. Again, we're not taking any derivatives in this video because everything is going to be provided for us. So let's get started. Let's try to do a lot of examples because I think that with these things, as long as, again, you know what you're looking for, you will be able to answer the question correctly. So now what we need to do is look at what we're looking for. So let's try to do some of these shape of curves, miscellaneous multiple choice questions. Not miscellaneous, multiple choice. So keep in mind that before we start, we do need to review the rules, of course. The rules are the most important thing. So let me just draw my normal grid of rules. So the best rule, the easiest rule is f is increasing when f prime is positive. So these are our shape of curves rules, of course. F is decreasing when f is negative. So when I do this, throughout sort of my process, I think about these rules all the time, and I might make little notes next to the answer choices about these rules. These rules help me eliminate wrong answers, and they'll help me sort of choose the right answer, which of course is what we're going for. In this box, we have f is concave up when f double prime is positive and when f prime is increasing. Same with the opposite, but concave down. F double prime is negative, f prime is decreasing. So this should be all review if you're following our playlist of shape of curves. But keep in mind that concave up or down is a little bit trickier than, in my opinion, increasing because there's two rules. There's f double prime is positive and f prime is increasing. And again, when we're dealing with these questions, usually there's going to be two questions in the that are part of the question. So for example, maybe the given graph is of f prime and then the question is about f. So if that's the case, it's pretty obvious what rule you want to use. Certainly f is concave up both when f double prime is positive and when f prime is increasing. But in my earlier example, if f prime is the given function, well, I'm going to use the f prime increasing rule. If I see a graph of f double prime, I'm immediately going to use the f double prime is positive rule. Let's continue with our rules. F local max. Remember that local max is the same thing as a relative max. They have the same words and we use them interchangeably. This occurs at points, so it's when f prime goes from positive to negative. Usually you're given an f prime graph, so you might not physically see a local max or a sort of a mountain or a hill, but again, you're going to be looking for where f prime is from positive to negative. So the opposite is a local min, f prime negative to positive. Finally, you have inflection points. F has an inflection point. It's similar to our rule over here because there's going to be two rules and you have to just choose which rule you want to use based off the given graphs. If we have something related to f prime, we're going to use this rule. F prime goes from increasing to decreasing or decreasing to increasing. And finally, if it's an f double prime graph, we're going to use that f double prime changes signs. So of course, being very familiar with the rules is a key part of this process. There are some confusing things that we've talked about in previous videos, like our f prime graph video, where notice that the word increasing appears multiple times throughout this grid. That's why it's important not just to know verbs and adjectives like concave up or increasing, but to know exactly what is increasing, exactly what is concave up. So for example, f is concave up when f prime is increasing. So if you're looking at an f prime graph, you're looking at literally where f prime is going up. If you want to know where f is increasing, well, that's where f prime is positive. So if you were looking at an f prime graph, then you would be looking at where thing is positive. So again, knowing the rules is very well, and then now the important thing is how to apply the rules. And again, in these questions, there's going to be two functions involved in the question, perhaps in the question and then in the answer choices. And what we want to think about is how these rules unite those two functions. So for example, we might have an f concave up graph, an f graph, just an f graph, and the answer choices might be all about f prime. So we're going to be using this rule, we're going to be using this rule, we're going to be using this rule. Things that have, when you look at a rule, it always has two sides. So you're using a rule that has two sides that deals with that question. So for example, f and f prime or f and f double prime. But it's kind of hard to see this without doing examples. So let's start doing examples. Feel free to copy these down, pause the video, copy these rules down, know these rules by heart, and now we're ready to apply the rules. So let's get started. So let's draw some nice pretty pictures today. Nothing too fancy. Let's say we have this. Let's say we cross at -2, 2. We'll just draw a nice easy picture. Let's say we have this, f prime. So I didn't really want to spend too much time drawing this picture, so let's leave it as this. And let's say we're doing an answer choice, multiple choice question. So the multiple choices that we're going to have is that f is increasing from x is equal to, this is -4 of course, to x is equal to -2. Then we're going to have the question answer choice, f is concave down when for x between -2 and 2. Let's do the question that f has a local max at x is equal to -2. Let's say 2. And then finally D, let's say f prime does not exist at x is equal to 0. So these are our answer choices. Again, our rules are going to help us choose the right answer choices, perhaps by eliminating the 3 wrong ones, or perhaps by just choosing the correct one. And then keep in mind that the question is, what is true about f? So just true or false. So there's going to be one statement that's true, and then 3 of them are false. So again, every single time I do this, the first thing I note, I don't look at the answer choice. I really try to make sure what the graph is of. If the graph is of f or f prime or f double prime, that highly changes the question. So in this case, our graph is for f prime, so we should note that. So let's just take every single question individually, and let's talk about our rules. So let's not look at the graph as we read the answer choice. What we're going to do is we're going to write a rule, and then afterwards we're going to look at the graph and see if it's satisfied. So for example, f is increasing. Well, I know that if I have an f prime graph, the rule is f is increasing when f prime is positive. So on the side here, I'm going to look at f prime as positive. So as I look at this graph, what I think about is that I need to see if f prime is positive, not where f prime is increasing, because we want to see where f is increasing based off whether f prime is positive. So I look at the graph and see where is if f prime is positive from -4 to -2. Well, if you look at from -4 to -2, f prime is negative, so that means that f is decreasing in that sort of interval. So that means that can't be the answer. So that's my strategy. Look at a question, note what the graph is of, so then I know I'm using the f prime rules. Then look at each answer choice individually, think about the rule that goes with that answer choice, and then see if the graph satisfies that answer choice. So let's do it for this one. Well, f is concave down. There are 2 rules, of course, about concave down. The first one is that f double prime is negative. The next one is that f prime is decreasing. Because I have an f prime graph, I'm not going to use the f double prime is negative rule, even if that's valid. I'll use that if that were an double prime graph. I'm going to use the rule that f is concave down when f prime is decreasing. See if I can squeeze the word decreasing right here. So f prime is decreasing. So now I'm about to look at the graph. And here I'm actually looking about whether f prime is literally going down. Remember, do not confuse about the words increasing and decreasing in these 2 slots. They're totally different. One is about f is increasing, and that's based off f prime is positive. One is about f is concave down, and that's based off f prime is decreasing. Unfortunately, they're the same word, but it's different things that are increasing or decreasing. So again, in the previous one, we wanted to see whether f prime is positive or negative, because that would tell me about my mysterious graph f, which I'm not going to draw, is increasing or decreasing. And in this case, if I look at this picture, I'm not going to be looking at whether f prime is positive or negative. I'm going to be looking at whether f prime, the graph that's provided, is increasing or decreasing, because that would tell me if my f graph, which again I'm not going to draw, is concave up or down. So if I look between -2 and 2, doesn't really matter if it's less than or equal to, between -2 and 2, notice that f prime is increasing first and then it's decreasing. So this is not strictly concave down because we have an increasing portion and a decreasing portion for f prime. And what it says is that f is concave down when f prime is decreasing. Because we have this increasing portion, this cannot be the case. So this is not true. So looks like we're just rolling down the questions slowly. Hopefully sort of my long explanations helps you sort of walk you through this process. Here, the next answer choice is f is local max. So again, I cover up the picture and I think about the rule. The rule is f prime goes from positive to negative. So when I look at this graph of f prime, what I want to expect is I'm looking for something where it crosses through the x-axis, f prime crosses through the x-axis, going positive to negative from left to right. So it looks like if we look at this number right here, well, it's negative to positive. That's not true. Let's look at the answer choice, what they want, the x value that they want me to look at. That's this point right here. Notice that it does, f prime does go from positive to negative. So while this doesn't look like a local max, you're finding a local max of f and not f prime. So f prime goes from positive to negative. This is the true statement. So that's that. Finally, let's look at this answer choice D, even if we know it's not the right answer choice because we know that answer choice C is correct. It says f prime does not exist at x equals 0. So a lot of students do choose this question because they know at sharp points f prime doesn't exist. But keep in mind that this is a graph of f prime. So if you look at this sharp point right here, I can actually tell you what the value of f prime is. It's whatever this y value is. Let's say it's 2. That is the derivative of at 0. I can tell you what f prime of 0 is. It is exactly 2. So it is f prime does exist there. I can tell you what exactly it is. But there is a sharp point here, so it means that some derivative does not exist because that is a true statement. Derivatives don't exist at sharp points. But it's not about f prime because f prime is the graph provided. What doesn't exist? It's the derivative of whatever this graph is. So the true statement would be f double prime doesn't exist because that is the prime of the derivative of the graph provided. So if this graph is f prime, because this one has a sharp point, it means that f prime's derivative, which happens to be f double prime, that one doesn't exist. So that's how you do these questions. So again, f double prime doesn't exist. F prime does exist. It is equal to whatever number you need, the y value here. So it's going to be 2. So this one was false as well. So again, that's my general strategy. Hopefully that makes sense. First, locate what the function is about. Then take your answer choices individually and consider the rules before you look at the question so that you know what you're looking for as you look at the graph. So for example, in this case, for part B, I know that the rule is f is concave down when f prime is decreasing. So I look at the graph and I'm looking for where f prime is decreasing. Don't get confused about the question function, which in this case is f, and then the graph provided f prime. Your picture is not going to reflect any sort of attribute about f. Because it's a graph of f prime, it's only going to have attributes about f prime. But there's rules that sort of tie f prime and f, and those are our main rules. So that's how you do this. Hopefully you saw our f prime graph video from that's the one that immediately preceded this video, so that you sort of have some sort of sense on how to do this already. Keep in mind that you can quickly answer the 4 main questions that we talked about earlier really quickly. Let me proceed for this question. So if we have this graph about f prime, I'm going to answer the main questions and then we'll move on to the next question. So where is f increasing? Well, it's where f prime is positive, so it's going to be between -2 and 2. Where is f decreasing? That's when f prime is negative. It's going to be between 2 and 4 and -4 and -2. Where is f concave up? Well, that's where f prime is increasing. It's going to be between -4 and 0. Where is f concave down? F prime is decreasing. That's going to be 0 to 4. Where is f have a local min? Well, local min is where f prime goes from negative to positive. That's going to be at x equals -2. Where does f have a local max? That was the answer choice. That's where f prime goes from positive to negative. That's at x equals 2. Finally, where does f have an inflection point? That's where f prime goes from increasing to decreasing or decreasing to increasing. That's going to be at the number 0, increasing to decreasing. So if you see that I can rattle off these answers, I don't have to think about it too much, a lot of work, because I just have a lot of practice with these questions. And I know the rules really well, and I know how to apply these rules to the graph. I know exactly what to look for. And if you know exactly how to look for, you're going to appreciate these questions more because, again, you don't have to take derivatives or draw sign charts or factor or anything like that. As long as you know what you're looking for, these questions are pretty simple because they repeat. They really can't be any trickier than anything else because it's just a graph. So let's answer a few more shape of curves questions that we might see in this fashion. So let's do something like this. So let's say we have this guy right here, and we have this, so bouncing, let's call this point. Let's call these points just random numbers. So let's call this one, let's say A, let's call this one B, let's call this C, we have 0, and then it keeps going forever. And then unlike the previous graph, this graph is going to be a graph of f double prime. So this is going to be a graph of f double prime. So hopefully my picture makes sense. A is this bottommost point right here. Actually, we need to write some different things down. This is embarrassing. Let me redraw this graph real quick. We have more points than I sort of foresaw. So we have this. Forgive me for sort of not being prepared for this, but we're going to have A, we're going to have B now, we're going to have 0, C, and D. Sorry about that, this is f double prime. So hopefully you can see that the 0 here is going to be A, the 0 here right here is D, finally this minimum is going to be B, this maximum is going to be C, and it crosses through at 0. And the question I'm going to ask is, where does f have an inflection point? So let's have some answer choices. Let's say the answer choice is A. Let's say the answer choice is A and 0. Then one of the answer choices is A, 0, and D. So maybe we should put only here. Another answer choice is B and C. And then maybe for D, we can put none of the above, because sometimes none of the above is certainly an answer choice. So again, what you want to do at the very beginning of any of these questions, you want to look at your graph carefully and just determine what is the graph of. Because if the graph is of f prime or f double prime, it highly affects the question. So in this case, our graph is of f double prime. So immediately when I read the question, which is only about inflection point, I think this question is a little bit easier because all the answer choices are about this one topic, where in the previous one we had 4 or 5 different topics, but we just had an inflection point. So what I would do is, I see f double prime, I have f inflection point, I would immediately try to write down the rule, and then we're going to try to apply the rule. So f has an inflection point. F has an inflection point. Again, there's 2 main rules. There's one rule which is f double prime changes signs. We're going to use that rule. And another rule is where f prime goes from increasing to decreasing. We are going to use the f double prime changes signs rule, of course, because we have a graph of f double prime. In the previous one, at the very end, when I was rattling off those answers, we used the fact that f prime goes from increasing to decreasing or decreasing to increasing to answer inflection points on that graph, because that graph was f prime. So let's do this question. Where does f have an inflection point? Where it's where f double prime changes sign. So now all I have to look at the answer. I have to look at the graph, keeping in mind that change of signs means it goes from negative to positive or positive to negative. So it looks like our answer choice is going to be A here, because notice that if we have this sort of rule and we have this sort of graph, looks like f double prime goes from positive to negative at x is equal to A, so that's where it changes signs, and also at 0, because f double prime goes from negative to positive. So this is the answer choice right here, and we are done. Keep in mind though that this answer choice B is a pretty tricky answer choice, because sometimes students only believe that f has an inflection point when f double prime is equal to 0, but bounces do not count. Notice that at D it's positive and then remains positive, F double prime I'm talking about. So that means that D is not an answer choice. Finally, how would B and C be an answer choice? Well, if you change this graph to be the graph of F prime as opposed to F double prime, again, the question just totally changes. So if this were a graph of F prime, then the inflection points would indeed be at B and C, because F prime, if this were a graph of F prime, so I'm just covering up one of these tick marks, if this were a graph of F prime, then F prime would be going from decreasing to increasing at B and increasing to decreasing at C. So those would be inflection points on F. So again, what the graph is of, that little label, graph of F prime, graph of F double prime, you really need to pay attention to that, because it will highly affect the question. And the answer choices aren't going to be random answer choices. They're going to be answer choices based on whether that graph was of F prime or F double prime or so on. But again, these questions, in my opinion, aren't too bad. I like writing the rule physically on the paper because it will be easier to apply a rule if you can see it sort of written in your own handwriting. Write down the rule, apply the rule, choose the right answer choice. So that's basically it. So let's do a few more questions, because sometimes they ask these questions that you might not know how to do if it was the first time you did these questions, but after you do a few, you're like, oh, these are actually easier than normal. So let's do this question right here. So I have this graph right here. I have the points -1, 0, and 1. Here my graph is going to be of F. And again, the graph is important. And what we're going to do is we're going to try to sort 3 different things. So the question sort of in English would be, what is true about this graph? And these are our 3 different things. So we're going to have F prime of -1. We're going to have F prime of 0 and F prime of 1. So F prime of -1. So potentially this could be the order. F prime of -1 could be the smallest thing. F prime of 0 could be the middle thing. F prime of 1 could be the biggest thing. Potentially this could be the order. Potentially this could be the order. Let's do another one. And then finally, potentially this could be the order. Let's just do something random. So what we're going to do is we're going to see, how do you sort these 3 numbers if I could find these 3 numbers? F prime of -1, F prime of 0, and F prime of 1. So we have a big hint for these sort of questions. They appear quite often on the AP exam. Our big hint is that when they have these 3 things and you need to sort, sometimes it's very hard to sort because these are arbitrary numbers. It's hard to tell if something is 6 or 7 or 8, and it'd be really hard to sort of sort them if you don't know exactly what these numbers are. So our big hint is that when you have these sort of 3 processes of sorting, one of them is going to be negative, one of them is going to be 0, and the third quantity is going to be positive. And hopefully you see that it will be very easy to sort once you know which one is which, because the negative one will be the smallest one, then 0 will be in the middle, and then the positive thing will be the biggest thing, because you have a negative number, you have 0, and then you have a positive thing. So they're easy to sort. So all we have to do is, I don't look at the answer choices, I just try to see which one is negative, which one is 0, and which one is positive. So in this case, again, the most important thing, hopefully you can see that this number is supposed to represent like the y-axis, of course. The most important thing is looking at what the graph is represented. So this graph is of F, and here the answer choices are about F prime. So let's talk about the rule that unites F and F prime before we go for the question. But keep in mind that it's not like the first one, for example, it's not a graph of F prime telling me about F. It's a graph of F prime, a graph of F telling me about F prime. But no matter what, we have something about F, we have something about F prime. Let's talk about the rules involving F and F prime. So the main rules, of course, is that F is increasing when F prime is positive. Again, we're trying to sort whether these numbers are negative or positive, so this is a great rule to use, because if we can sort of know this fact, then we'll know which one is positive. And finally, F is decreasing when F prime is negative. Another way to think about this is through slope, of course. So let's look at the point -1. So this is the point -1 right here. And what we want to think about is F prime and -1, is that positive or is that negative? So notice that if you're traveling along the curve -1, just having your own nice merry day, and you're traveling along the curve, notice that you're increasing. Another way to say this is that the slope of F is positive. So what is f prime of negative 1? While we might not be able to find it exactly, what we know is that it's going to be a positive number. Because, again, f is increasing at the point negative 1, so it's going to be going up at that point. So let's do the same thing with 1. So if we consider the point 1, well, at this point 1, f is decreasing. It's literally going down. If you're riding this as a roller coaster, you would be going down as you hit across the point 1. Another way to think about this is that the slope of f at this point is negative. The slope is the derivative, so that means f prime is negative here. So we don't know exactly what f prime of 1 is, but we know that it's negative. So finally, we want to find f prime of 0. That one's a little bit trickier because notice it's a little flat little line because 0 is the local max or the absolute max of this function right here. So there's a horizontal tangent line. Again, f prime is just slope values. What's the slope of this line? It's just 0. So f prime of 0 equals 0. Hopefully you see that from this 3 information, we're going to be able to sort them, even again, if we don't know exactly what f prime of negative 1 is and f prime of 1 is, because we know which one is negative, which one is positive, and which one is 0. So it looks like this is going to be my smallest thing, the negative, f prime of 1. Then it's going to go to the middle thing, which is f prime of 0. And finally, the biggest thing is f prime of negative 1. So it looks like my answer choice is going to be C. The negative thing, 0, and then the positive thing. So that's our main hint with these questions. The answer choices look pretty similar, of course. You just have negative, negative, or inequality, 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 and you just want to find which one's negative, which one is 0, which one's positive, based off our shape of curves rules, just like normal. But keep in mind that the graph of f, the fact that this is a graph of f is very important. If, for example, this was a graph of f prime, then all of your rulers would be changing. So let's do another one of these inequality questions, and then we'll have one more after that. So let me erase this. So let's erase this. Let's do something like this. So we're going to have this guy right here. And instead of dealing with 3 points, let's just deal with the same single point. So we're going to have a graph of f as well. We're going to have this point 1, and our graph is going to look something like this. And we're going to try to sort 3 other things. So first thing we're going to try to sort, the 3 things we're going to sort are f of 0, f of 1, f prime of 1, and f double prime of 1. So perhaps this is the order. F of 1, f prime of 1, and f double prime of 1. Perhaps it's all reverse. F double prime of 1, f prime of 1, and f of 1. Perhaps f of 1 is in the middle. So again, these are answer choices. So what I suggest is trying to eliminate answers or go through the questions. It is still a standardized test, so you can sort of make your life easier, even if you don't know the answer exactly. So we're going to do f of 1 in the middle, and then we're going to switch them. So these are my 4 answer choices. One of them will be correct, one of them will be wrong, just like normal answer choices. So let's get started. Again, you don't even need to look at the answer choices too much as long as you know which 3 things you're trying to sort. So it looks like I'm trying to sort f double prime here of 1. I'm going to try to sort f prime of 1. We can just do them in order. Let's sort f of 1, f prime of 1, and f double prime of 1. And similar to the last question, one of them is going to be negative, one of the quantities is going to be 0, one of the quantities is going to be positive, and that's how we're going to sort it. The negative thing, then 0, then the positive thing. So let's just take these things individually. Again, what's very important is which graph we're dealing with. In this case, we're dealing with a graph of f, so that's going to change sort of and dictate what these values are. Even if we can't find the values exactly, at least we'll know the sign or whether it's 0. So the easiest one is f of 1. Notice that this is a graph of f. So if this is a graph of f and it crosses the axis, x-axis at that point, x equals 1, that means that 1 is a 0 of this graph, f of 1 is equal to 0. It's the y value of this graph because this graph is of f. Then if you have f prime of 1, remember of course that f prime of 1, that's dictated whether f is increasing or decreasing. F is increasing when f prime is positive, f is decreasing when f prime is negative. So in this case we have f prime of 1. Looks like we are decreasing along this curve. Another way to think about this is that the slope is negative. The slope is the derivative, so that means f prime of 1 is negative. We might not know it exactly, but at least we know it's negative. For example, we know that this is smaller than this number. Finally, f double prime of 1. Here you actually use the definition in concavity. F double prime and f, you think about the rule that combines and unites them. That's f is concave up when f double prime is positive. You could use the fact that f prime is increasing, but because f prime is not either a graph of f or f double prime, I don't want to use that rule. I want to use the rule that f is concave up when f double prime is positive, f is concave down when f double prime is negative. So in this case, it looks like we are part of a U, a pretty wide U, but we're still part of a U. We're open to the sky, which means we are concave up. We are actually looking about concave up because the rule is f is concave up or down when f double prime is positive or negative. Usually it's the reverse. Usually we have an f double prime graph where we're looking at positive and negative to tell me about the concavity of f. And in this case, we're doing sort of the normal thing that we need to do. Look at a graph of f and talk about f double prime. So in this case, because f is concave up, it means that f double prime of 1 is going to be positive. Finally, if you know this information, you should be able to sort them. Looks like this is the smallest one because it's the negative quantity. So we want f prime of 1 to be the first slot. Then it looks like we want f of 1 to be in the middle because that's the 0. Finally, f double prime is positive. So this is the answer choice in this case. So hopefully you can see how I'm using these shape of curves questions to quickly answer these multiple choice questions where the graph is already provided. I don't try to draw anything because I'm not an artist and it would really clutter my pictures, or I would just draw it off a picture and I'd probably miss the question. I just use my shape of curves rules to answer these questions. Let's do one more. So let's do ones where people get a little bit confused because both the answer choices and the questions are of f. So I'm going to have a nice f graph provided. So we're going to have this graph. So this is f. And then we're going to say which of the following is a graph of f prime. So we're going to have A, B, C, and D. So we're going to have the graph itself. So this is probably not the answer. Sorry to spoil things. Is this the graph of f prime? We're going to have the upside down version. Is this the graph of f prime? My next thing is to see if this is f prime. And finally, my last one is to see if this is f prime. So this is not the most perfect pictures in the world. Sorry about that because I can't draw perfectly accurately, but hopefully you sort of get the idea. If this is f, which of the 4 answer choices is f prime? And this is true that what I was intending is a sine graph, and you might know that the derivative of sine is cosine, so you'll know that C is the answer because that is a picture of cosine. But what I'm going to do is I'm going to pretend that I don't know any trigonometry, I don't know any derivatives. I'm just going to use my shape of curves rules to try to answer this question. And what we're going to do when we have a graph and a graph where both the question and the answer choices are both graphs, we're going to use a two-pronged strategy, a two-step strategy. My first strategy is going to be asking about increasing or decreasing. F is increasing or decreasing. Because if I know where F is increasing or decreasing, I know where F prime is positive or negative, because that's the rule. Then I'm going to use talk about F is concave up or down to try to get the final answer. So what's the rule about F concave up or F concave down? Again, there's two rules. There's F double prime is positive and a negative, and there's F prime is increasing or decreasing. But because this is a graph of F and F prime, I'm not going to use that F double prime rule. I'm going to use that F prime is increasing or F prime is decreasing. And keep in mind that usually if you apply one rule correctly, you'll be able to whittle down the answers to the 2. And that's obviously great because if you're guessing randomly, it's better to guess from 2 than 4. So the rule will be, this would allow us to roll it down to 2, and then this will probably allow us to roll it down to the final answer. So it's a two-pronged strategy. Again, we're going to look at this, and then we're going to look at this. Another thing is that usually if you look at a small portion of the graph and then you can apply these rules, you're going to be able to answer the question. So what I'm going to do is I'm only going to look at the first quarter of this graph, basically from here to here. So from here to here, that's all I'm looking at. So again, let's try to apply these strategies. So keep in mind, the biggest thing is knowing which one is F and which one is F prime. These labels, again, are very, very important. That's what I've been trying to stress throughout the video. If this were F prime and all of these graphs were F, then the question would be, of course, totally different. But in this case, we're dealing with F first. So notice I can physically see where F is increasing. Looks like it's from here all the way up to here. At the portion that I'm examining sort of in a very sort of careful way, the first part of the graph, F is increasing. So what I want to look at in my F prime graph is something that F prime is positive. So for example, this theoretically could be the answer because f prime is positive on this portion of the graph. Then this one could be potentially the answer because notice that in the first portion of my graph, I want something to be f prime is positive because the first portion of my f graph is increasing. If I look at this graph cannot be the answer because again, the first portion of my f graph is increasing. The rule is f is increasing when f prime is positive. F prime doesn't start increasing in this graph, it starts decreasing. So this cannot be the answer. I can rule it out, I can eliminate it, which is great. Same thing with answer choice D. Again, f is increasing when f prime is positive, so you're looking for something that starts off positive. But in this case, this graph starts off negative. It starts below the axis. So there's no way that this can be a graph of the derivative of f because f is increasing when f prime is positive and this is negative, so it can't be it. So just by looking at the first portion and thinking about increasing or decreasing, notice I was able to eliminate the answer choices to just to A and C. Finally, we're going to look at this small portion again, and we're going to use the fact that f is concave up when f prime is increasing and f is concave down when f prime is decreasing to see which of these two answer choices is the answer. Again, my graphs aren't perfect, but hopefully you sort of see what I'm going for here. So I'm going to look at concave up or down. So I look at my first portion and I see, is this concave up or down for f? And because I'm dealing with a graph of f, I'm actually looking at concavity. If I'm dealing a concave up or down question and the graph is of f prime, I would be looking at where things are increasing or decreasing. If I was dealing with a concavity question and my graph was of f double prime, I'd be looking at where things are positive or negative. But because we have a graph of f, I'm looking at where f is literally concave down. So notice that the first portion of our graph is part of a upside down U. It's open towards the floor or towards the ground. So that means that this portion of the function at the very beginning is f is concave down. My marker is dying, but we don't need it too much, but f is concave down. What happens when f is concave down? Well, that means that I want something where f prime is decreasing. So at the beginning of my f prime graph, I need to be decreasing. Notice that the answer choice A cannot be the answer choice because when I start off my graph, it starts literally going up immediately. And that would mean that f is concave up, but f is not concave up in this case, so that can't be the answer choice. So now that we rolled it down to 3, again, C is the answer choice, but notice it does satisfy that concave down rule that we want. F is concave down at the very beginning of this graph, so we want to see something that's decreasing. Notice that this graph is decreasing as long as it's more perfectly drawn, but at the very beginning of this graph, it's decreasing. So it's literally going down. This is the correct answer choice. Again, look at this small portion of this graph and you'll notice that C satisfies the two things we want. We want f to be increasing, so we want f prime to be positive, and then we want f to be concave down, so we want f prime to be decreasing. So when I look at this graph, I immediately know I want something at the very beginning that is above the line, it's positive f prime, and then also that it's going down, decreasing. So something above the line and decreasing. This is the only graph that starts above the x-axis and is decreasing. So that's the answer choice. So hopefully I've sort of given you a flavor and strategies and hints on how to graph these f prime, how to do these f prime, f double prime, sign chart, shape of curves, multiple choice questions. So keep in mind, the most important thing is just knowing the rules really, really well. And not just knowing the rules, but knowing how to apply the rules and knowing what to look for. And what to look for is dictated by what your question graph is and what your answer choice questions are, because that's usually the rule you're going to use. So for example, if the question's about f concave up and you have an f prime picture, you're going to use the rule f is concave up when f prime is increasing. But if the question's about f is concave up and you have an f double prime picture, you're going to be using a separate rule. F is concave up when f double prime is positive. So we use those rules sort of to find our answer choices for a lot of things. Keeping in mind that we really pinpointed what graphs we were dealing with. That's the easiest step, but it's a step that I think is necessary. We also saw some questions where all the answer choices were inequalities. And what we did is we found that one quantity is usually negative, one quantity is usually 0, and one quantity is usually positive. And that's how we were allowed to sort them, even if we couldn't find those values exactly. And how to determine whether something was negative or positive, we use our rules, of course. Finally, when we have graphs where, or multiple choice questions where graphs are part of the answer and the question, here's a graph of f, try to find a graph of f prime. We use our shape of curves rules again, of course. And what we did is we did a two-strategy system. We saw where something is increasing or decreasing, and then we saw where something was concave up or down, with f prime positive or f prime increasing respectively. But again, these questions are sometimes pretty tricky. What I would encourage you to do is just practice as many as possible. And we do have a Girls Teach Calculus video where one of my former students practiced several of these questions, sort of our longest worksheet that we have. And she just goes through them step by step. She answers the questions really fully. She'll go through each answer choice and try to explain why certain answer choices are not just right, but why the other ones are wrong. So we highly encourage you to watch that video. I'll link that in the description of this video if you want more practice of these shape of curves questions. Keeping in mind that on an AP exam, for example, no matter if you're taking A, B, or BC, these might be 3 to 4 of the 45 multiple choice questions on the test. But hopefully this has been beneficial for you. This is a very crucial topic, so we did want to spend a lot of time on it. If you have learned something, give us a like and subscribe. We certainly appreciate that. But no matter what, I hope to see you next time when we have another Shape of Curves video. Thanks again for watching.